Okay, so a question about mains electricity here. First part is a recall. So what is the frequency and potential difference of the mains supply in the UK? So our frequency in the UK is 50 hertz and the potential difference is 230 volts. Okay, so then we're told that the vending machine can identify the value of the coin by measuring the resistance. We are given a power for the coin and a current, and we are asked to calculate the resistance using our equation sheet. So we're looking for an equation that links together power, current, and resistance, and that is P equals I squared R. So we want to rearrange that to make R the subject. So R is P divided by I squared. So if we then find our value for P, we can see that P is equal to 340 MW. Now that is milliwatts. So 1 milliwatt is 1,000th of a watt. And therefore 1 milliwatt is equal to 1 times 10 to the minus 3 watts. So when we plug that back into our equation, we have the power will be 340 times 10 to the minus 3 watts, divided by our current of 0.75, and we must remember to square that, and when we then work that out we end up with a value of 0.6 ohms. Coins that are dirty and not recognised suggest one reason why. Well, as the top of the question says, it is the resistance of the coin that allows the machine to verify what the value is, and therefore actually the dirt would change the measured resistance. Now, we could alternatively say that the resistance that was measured would be different to what the machine would expect. 5.4 shows us a circuit used to monitor temperature in a vending machine, and they haven't entered the symbol for the thermistor, so we're asked to draw the circuit symbol for the thermistor. So the thermistor is a resistor at the base, and then we have that one running through it there. So now we're given some information about how the resistance of the thermistor varies with temperature, and we are told that the cooling system is going to turn on when the temperature of the thermistor is above 20 degrees. So we are asked to calculate the PD across the thermistor when this 20 degrees is reached. So quite a few things to have to do here. The first thing to do is to identify, well, what is the resistance of our thermistor at 20 degrees? So we can use the graph to do that. And we can see that the resistance of the thermistor at 20 degrees is equal to 80 ohms. Now from that, if we look back at our circuit diagram, we can see that the resistance of the fixed resistor is 400 ohms. And therefore we can work out the total resistance in our circuit because we know that resistors in series add up. So the total resistance in our circuit will be 400 plus 80, which is 480 ohms. Now from that we can work out the current that is in our circuit because the current in a series circuit is the same all the way through. So we can now say, okay, well, we know that current is PD divided by resistance. And we can see from our circuit diagram that our PD is 12 volts. And we've already calculated our total resistance in a circuit of 480. So that gives us a value for the current of 0.025 amps. So that's now the total current in the circuit, and that current is the same in the fixed resistor and the thermistor. But we're after the PD across the thermistor. So now we need to go back to our formula for PD, V equals I times R, and we know that the current, as we've just seen, is 0.025. The resistance of the thermistor is 80, so we multiply that current by that resistance, and that will give us 2 volts. Now there is another way to do this. You still have to read off the value for the thermistor of being 80 ohms, but another way of doing this is to remember that in a series circuit the PD will split, and it will split in the same ratio as the resistance. So the higher the resistance, the higher the PD across that component, because it means the charges are having to work harder to move through it. So if we look at the fact that the total resistance is still 480, and we say, well, okay, what proportion of that total resistance is that 80? Because if we can find out what that is, that will be the same as the proportion of the PD. So if we work out the ratio of 80 ohms out of the 480, we find that that ratio is a sixth. So a sixth of the total resistance is across the thermistor, and that means the PD across the thermistor is going to be a sixth of that total 12 volts, and that will also give us our value of 2 volts.